In the last section, we created an hello world, and we added SVG tag into our JSX code, and it may look like HTML, but it's not. As you know, the JSX, which stands for JavaScript Extension Code, it mimics HTML, but it's not HTML. So to really understand why React does that, you need to really understand what's happening behind the hood. So we have the DOM, the document object model, that React process your JSX code in the background before it's committing those changes into the user browser in order to speed up how quickly the user page loads. So it can control and it can check for changes and only render or re-render the DOM when it's needed. And React team really put an effort to match the HTML and the JSX so it can support all the different tags and all the different attributes, but there are certain changes that you may see between the HTML and the JSX. So although React put the effort, there's still some changes. Now in terms of SVG, as you see here, what the code we wrote before, the SVG stands for Scalable Vector Graphic. It's an XML-based markup language. It was last updated in 2016, and each one of those tags, like rectangle, circle, whatever object you want to use, it has different attributes, and it's good to really understand all of them and learn them. Now, if you want to have a better understanding, you can go to GitHub, the W3C, and it shows you the latest SVG2. That's the latest one that got released in 2016, and it shows you all the different attributes and the different graphics you have and elements you have. So I would recommend you go through this and just check all the different and learn more about all the different attributes and what you can do. Here's, for example, the transform reuse. It shows you the changes between the version 1 and version 2. So I highly recommend going through that and reviewing that. Now, the SVG element includes many different types of graphic, and each element has its own sets of attributes. So most developers are really unaware of all those attributes and all those graphic. I really recommend you go through that. Now, the other option other than SVG is to use HTML. Now, SVG is the standard, but there's times that you want to use HTML over SVG. Now, in order to draw and animate in HTML, we use the canvas element in JavaScript. Now, the canvas element is a container for graphics. The SVG gives us a better performance with a small number of objects or a larger surface. So meaning if you have a larger surface like a desktop, a large screen, then the SVG will give you better performance and it will draw nicely because it has that print crisp look. However, on a small devices, you don't need that quality, and you're paying for it in performance because it's rendering everything in a pixel print level. So on a small screen, if you need to draw a lot of graphics and you're on a small screen, you're better off with HTML, and we do that with Canvas. So a quick showdown between SVG and HTML is that the SVG allowing us to style with CSS. The Canvas, we're not going to be able to style, and we're going to have to do it through scripts. The SVG is vector-based, the Canvas is raster-based. The SVG gives us a better scalability versus the Canvas. So once the element needs scaling, the SVG is better because once you're going to scale, it's not going to get blurry. Then the SVG has performance advantage over Canvas for larger screen and low number of objects. However, for smaller screen and large number of objects, the Canvas has an advantage. The JSX Canvas can be used to draw component in HTML, and it's the standard for creating graphic and animation on mobile. So what I want to do is I want to show you, even though we're not working here in mobile, I want to show you that option so you're aware of it and you know how to work with it. What we're going to do is we're going to create another component just like we did with the Hello D3. This time we're going to use the Canvas. Now to create our Canvas component, what we can do is, if we want to speed it up, I can just use the generate CLI component. What I can do is just use, if you open up the README, I left you some shortcuts how you can generate those. So in terminal, again, we just type in the npx generate react CLI and then the component, and then the name, let's call it JSX Canvas, and the type, oops, I have a typo there, doesn't let me stop. I need a space here. The type is going to be D3, and that's going to generate for us those 3 files in the component folder, and we can just change that. So we got, the scaffolding, and then we can work with that. It's much quicker than writing all that code. If we go to the canvas, now let's take a look. We don't need the state, so I delete that. The next thing, we're going to use the draw reference. The draw, we're going to change it, so let's delete that. And on the rendering side, we don't need the SVG because we're going to use the canvas. So just close the tag here. Okay, great. So now we got our scaffolding for our element. So the first thing we want to do is we want to render a canvas. So just add the canvas. Here you go. And close that. Now if we go back to app, our entry point, app TSX, just add the canvas. Oops. I'm sorry, add the JSX Canvas component we just created. Close the tag. And if everything went well, let's just do a sanity check. We should actually see nothing on the screen at this point. So refresh. Okay, it didn't break, so we're in good shape. Now that we have the canvas, we want to again reference the canvas. So what we need to do, we have a reference. Let's rename this reference so it's easy to understand what's happening here. Let's call it canvas reference. Now let's look at the difference here. If you click the canvas to find out the type, you can see that the type of the canvas is of HTML canvas element, right? So it's either here it is, HTML canvas element. So here, if you remember the reference, we set it of type HTML div element. Just change it to HTML canvas element, and that's gonna create the reference for us. Now in the draw method, we're using the use effect. So the use effect is being called after the component gets rendered and on every change. So we're not implementing any, we're not checking when to render, but we'll do that later. We're using the memorize, but at least we know that it's going to get called after the component get initialized. So what we can do is we can create a canvas constant, and what we're going to do is we're going to take the reference, the current, so that's going to give us the current reference of the canvas. And then the next thing is we need in canvas, we need the context. So inside the context, that's where you're actually rendering everything. That's where you're adding your drawing and element. So what we're going to do is we're going to use canvas. Now, then we're going to do get context. And we're going to do the 2D. Now, if you look at the Mozilla document, we have the canvas rendering context 2D. That's, I'm at the developer.mozilla.org, and it's explaining what it is. This is the interface. It's part of the Canvas API, and that's where you add those drawing elements like shape, text, and other object. And it gives you an example how to work with it. So we need to set our context, and look what happened. It added us a question mark automatically. The reason is that we need to avoid that we have a situation of a racetrack that the context did not get created. So when we first rendered the component, the context may have not been created yet. So we're checking if the canvas got created and added to the DOM, only then get the context of the 2D. So that's really important in order to avoid errors. And what we can do is we can actually check that if the context is created after it was added to the screen, only then we want to draw, add our drawing. So if that happened, what we're going to do is we're going to create a constant, and in our constant we're going to take we're going to set the device pixel ratio. So when we work with the canvas, we need to work with the device pixel ratio. I'm going to show it to you in a second. You're going to understand that. And the ratio that we're going to set is going to be 1. And we're going to get that from our window. Once we do that, then we can set the context.scale, and we're going to set the ratio of our canvas. Now again, if we go back and look at the Mozilla doc, the device pixel ratio, that's the window interface of the resolution of the physical pixel. So that's how we set the pixel, because we want to make sure that our component is not pixelated. So we have an option with the canvas to set our pixel ratio. A value of 1 indicate a classic 96 dpi, a value of 2 it's for high definition retina display. So we're setting it for 1 for lower resolution. I have an error here on the context. Okay, now the next thing we want to do is, just like we did with an SVG, the context also has a fill. It's just, if you remember in SVG, it's called fill. In Canvas, it's called fill style. And I'm going to set it to a color tomato. And then if I call the context, now I can fill my rectangle, and the API wants me to set the X and the Y, and the context canvas, the width and the height. So I'm going to set the width, and I'm going to set context canvas height. Let me see, height. There you go. And that's about it. Now, if everything went well, we should see a rectangle. So go back to localhost, refresh. I'm not getting it. Let's see why. My code should have been good to go. On the canvas, I didn't set the reference. So we need to set the reference, which is the canvas reference. Now go back into our, here we go.